Well, good morning, class. Today we are going to review the radicals, specifically square roots. So on number one, hope you can see that, we're going to break down each item here into separate radicals. The -2 is times that, so it doesn't break down any further. Now, I happen to know that the square root of 180 breaks down into the square root of 36 times the square root of 5. Now, you probably would not know that. So, go into your calculator and put 180 divided by x, and then go look at the table, and it will give you the right factors, and you'll find the largest perfect square, because that's what we're trying to do. Now, x cubed, we're going to break down into x squared times x to the 1, because x cubed is not a perfect square, but any even power is. And we'll leave square root of y squared just the way it is. Now, let's break it down. We got -2 times square root of 36 is 6, times the square root of 5. Square root of x squared is x. Square root of x is in simplest form, and the square root of y squared is y. Then the final thing we do is that we multiply everything that's not under the radical sign. So -2 times 6 is -12 times x times y times, and then we put everything under the radical signs together. So -12xy times the square root of 5x. All right, number 2. Here we've got a binomial squared, and a common mistake students make is they want to square every term here, but that's not right. And the reason is that a binomial squared is the binomial times the binomial. So we've got square root of 5 plus square root of 2 times the square root of 5 plus the square root of 2. Now we use the usual distributive property. The square root of 5 times square root of 5 is the square root of 25. The square root of 5 times the square root of 2 is the square root of 10. There we go. And 2 times the square root of 2 times square root of 5 is, again, the square root of 10. And square root of 2 times square root of 2 is the square root of 4, which you're already thinking those are perfect squares, and indeed they are. So square root of 25 is 5. 1 square root of 10 plus 1 square root of 10 is 2 square roots of 10, plus square root of 4 is 2, and then we add up the 5 and the 2, and we get 7 plus 2 square roots of 10. Well, I just now realized that I got things out of order. That the one I just did was number 3. So let's go back to number 2. Here we've got distributive property. But you want to keep in mind, guys, that a radicand can only get multiplied by another radicand. So in this case, -4 squared roots of 3 times 5 is -4 times 5, which is -20 square roots of 3. Then -4 square roots of 3 times the square root of 6 is -4 square roots of 18. Square root of 3 is in simplest form, but 18 is not. So 18 divides up into 9 times 2. Again, you're looking for perfect squares. 6 times 3 won't help us. So we have -2 square roots of 3 minus 2 times 3 times the square root of 2. 2 times 3 obviously is 6. So -20 square roots of 3 minus 6 square roots of 2. And hopefully you remember that you cannot add unlike radicands. And that was actually number 2. All right, here we've got, what number is this? Number 4. And so we're going to go square root of 5 times square root of 5, square root of 25. Square root of 5 times 1 is plus 1 square roots of 5. Normally, I don't put the 1 there, but I just want you to see what we're doing when we combine those. 4 times the square root of 5 is 4 square roots of 5, and 4 times 1 is 4. Well, square root of 25 is 5, and let's combine these. 1 square root of 5 plus 4 square roots of 5 is 5 square roots of 5, plus that number 4, so 5 plus 4 would be 9 plus 5 square roots of 5. All right, with number 5, we've got 3 terms with unlike radicands. However, we can break them down into things that have perfect squares. So instead of 2 times the square root of 54, we'll call that 2 times the square root of 9 times the square root of 6. Minus 24 will break down into 4 times the square root of 6. Minus 20 would be the square root of 4 times the square root of 5. Now, notice again, put the perfect squares first when you're listing these factors. All right, so square root of 9 is 3. 3 times that, 2 is 6. So we have 6 square roots of 6 minus square root of 4 is 2, 2 square roots of 6 minus square root of 4 is 2, 2 square roots of 5. Now what we can combine now is 6 minus 2. So we get 4 square roots of 6 minus 2 square roots of 5. And there we have it. Okay, number 6. As I look at this radical fraction, I can see that the 8 can break down further, but I'm going to deal with that square root of 3 that's in the denominator, because you may remember that we can't leave that there. So we have a math trick where we rationalize the denominator. Whatever that radical is we multiply that fraction by it over itself, because that's essentially the number 1 and it doesn't change the value. Then let's go multiply side by side. So we have 8 times the square root of 24, 8 times 3, over square root of 3 times the square root of 3 is the square root of 9, which is the number 3. Now let's deal with that 24. 24 is 4 times 6. And let's see here. So the square root of 4 is 2. 2 times 8 is 16. Square roots of 6 over 3. Now at this point, if 16 did divide evenly by 3, we would, but it doesn't, so we leave it alone, and that would be